In today's lesson, you'll be learning about one-to-one functions. What is a one-to-one function? How does a one-to-one function differ from a function? And what is an inverse function? And what does it look like graphically? Well, let's address the first question. What is a one-to-one function? Well, if you look below, on the left here, we have a series of inputs, we'll call that A, and outputs, we'll call that B. You'll notice that a one-to-one function matches each element of the input with a different element of the output. Whereas on this one over here, this is not a one-to-one function. Notice that we have individual elements on the input, but two of these are going to the same element on the output. So it is not a one-to-one function. Think of a one-to-one function just like it sounds. There can only be unique x coordinates corresponded to y coordinates. How about our second question? How does a one-to-one function differ from a function? Well, here we have our two diagrams. Let's look at our third diagram. In both the first two diagrams, these are functions because we have one input matched with an output. It's okay in this second one that we have two different inputs matched with the same output. As long as we have each input matched with an output, it's okay. The problem is in this one, when we have 4, we have an input twice. So we have the input 4 in here twice because 4 is matched with a 4 as an output and 4 is matched with a 3 as an output. So that's not even a function. So one-to-one functions where unique x coordinates correspond to y coordinates, whereas functions, each x coordinate input must have exactly one y coordinate output. Let's continue to examine that question. So let's look at it graphically. Well, if you remember that functions must pass the vertical line test. So in other words, if you draw a vertical line, it can only intersect your graph in one location. If we look back at this diagram here and you picture what that would look like graphically, you have, we'll draw an image. So you have a graph and you have an output of 4. So if x is 4, and we'll say that this is 4, it can be mapped to 4 up here on the y, and we'll say that's 4. But it can also be mapped to 3 here on the y. So if in fact I were to draw a vertical line through this graph, it would hit, my line's not that straight, but it would hit these 2 points. Therefore, it is indeed not a function. So if we look at this, let's determine. We're going to circle, is this a function? Is it a one-to-one function? Well, first of all, let's look and see if it's a function. I could draw a horizontal line anywhere, and it will not intercept any part of my function more than once. Notice here we have a hole and a solid. So if I were to draw a line straight down the middle here, it would only intercept the graph here where we have a solid dot. So we know in fact that it is a function. How about one-to-one? Well, one-to-one means that we need exactly one input paired with exactly one output, that we cannot have two of either. And if you'll notice down here, a one-to-one function must pass both the vertical and the horizontal line test. Well, does this pass a horizontal line test? Notice here, if we draw a line, it does not pass a horizontal line test. So this is not a one-to-one function. So it is only a function. Let's think about why it needs to pass the horizontal line test before we move on. So let's think about our points. We have a point here at 1, 3, and I could choose any of my points on each leg, but I'm going to choose these since they have solid dots there. This one is 3, 3. So think about what we know about one-to-one functions. We have 1 mapped to 3, but then we also have 3 mapped to 3. And remember that we have to have unique inputs matched with outputs, and this is not the case. Let's look at another example. How about here? Is this a function? Well, right away you can see that it will indeed pass a vertical line test, so it is a function. How about a horizontal line test? looks to me like it will pass the horizontal line test. So in fact, it's a one-to-one function as well. So remember, in order to be a one-to-one function, the original function must pass both the vertical and the horizontal line test. Let's look at this, the last question. What is an inverse function and what does it look like graphically? Well, the reason we're bringing up an inverse function is because in order to have an inverse of a function, you must have a one-to-one function. Now, one thing you should know is that every function has an inverse, but the inverse may not always be a function. That's where the one-to-one function comes into play. So let's look here. Here we said we have a function and it's one-to-one. So here's our original function, and I've just expanded it so you can see beyond the 0, -1 coordinate. Here's our inverse. Notice this. When we have an inverse, the domain and range are just switched. In other words, the inverse reverses the action of the function. If we look at it graphically, the inverse is just a reflection of our function over the line y = x. This is going to be very important in our next couple of lessons. So, an inverse is a reflection of a function over the line y = x. If I were to draw in that line, right in through here, you can see that these two reflect over that line. And remember, in order for an inverse to still be a function, the function must have been a one-to-one function. We know this one is, so therefore the inverse is also a function. We can also look at the inverse once it's graphed and determine if that does pass the vertical line test. If it does, we know it's a function. Let's try some basic examples. So we want to find the inverse and determine whether the inverse represents a function. So given this, f of x, our inverse notation is written as f inverse x. So the inverse, remember, means that we just flip or reverse x and y. In other words, the inverse undoes the function. So think about our function machines. If we input a -3, we output a -27. When we take the inverse, instead we put back in the -27 and we would get our original output of -3. So we would continue to do this for all of these points and we would just reverse them. So let's look at our original function. Is this one-to-one? And if you'll notice, each unique input has an output. And none of the outputs are duplicated. So this is a one-to-one function. So if I look at my inverse and see if that's a function, well, what I'm looking for is my inputs. I don't see any duplication on my inputs. So based on that alone, it's a function. But if I go back to my original function, I can see that it's one-to-one. So yes, this is the inverse here, and it does in fact represent a function. So how about the second one? Before I write the inverse, let's notice, is this one-to-one? Take a second and think about it. Okay, notice we have an output of 1 and another output of 1. We can't have that and have a one-to-one function. We also have an output of 4 and another output of 4. So both those situations cause this to not be a one-to-one function. We can create an inverse, but it will not be a function. So here's our inverse. If we look at our inverse and determine, is our inverse a function? We can look at our inputs and we can see that, oh, here we have an input of 1 and an input of 1 with two separate outputs, which means this will not pass the vertical line test. Same thing with the input of 4 and the input of 4. That won't pass the vertical line test. So while this is in fact the inverse, it is not a function. So this one is not. Let's look at our last example on this page. So in this case, we don't need to sketch in the inverse. We can look at this function and we can apply the vertical as well as a horizontal line test anywhere on this function. And as long as we don't cross the function more than once, we know that the function and the inverse represents a function. Now, if we want to go ahead and find the inverse, and in fact the directions say that, we would need to pick some points and reverse them. So we've got 0, 0, which would stay 0, 0. We have a point here which looks like it's at 1, 1, so that would stay 1, 1. And then we have a point here which is at negative 1, negative 1. So knowing that the inverse will intersect these same points, the inverse will look something like this because it's going to be reflected over the line y equals x. That's a rough sketch. Let's try to be a little more precise. Here's another function. Let's find the inverse. So this point 3, 3 would reverse and still remain 3, 3. This point 0, 2 would reverse and now become 2, 0, so it'd be approximately here. Then we have negative 2, 0, which would become 0, negative 2, and that would be here. And finally, we have negative 3, negative 1, so that would become negative 1, negative 3. And then we would just connect. Now we can see our inverse compared to our function, and you can tell that in fact it does reflect over the line y equals x. And if we were to sketch that line in, you can get a better visual. So let's think about this as we wrap up. A function and its inverse just means that x and y are reversed. So if you'll notice, we have y equals x, that just becomes x equals y. We're going to use this when we are looking at finding the inverse graphically in our lessons coming up. So at the end of this introductory lesson, you should be able to answer what a one-to-one function is and compare it to a regular function. You should also be able to identify how a one-to-one function differs from a regular function, how they look graphically, and how you can apply the vertical and horizontal line tests to determine if a function is in fact a function and if its inverse is a function.